Hello, everyone, and welcome to today's event. My name is Russ Danner. I'm VP of Products and Customer Success here at Crafter CMS. We've got a great topic today on implementing DevContentOps for you. Now, the writing is on the wall. We want more digital experience, more connections between our experiences, and more personalized experiences across more channels than ever before, and we want them sooner. So composing and managing and delivering these experiences can be pretty daunting because it involves creative, technical, and operational expertise and resources, and really requires a multidisciplinary team to get it done. So DevContentOps is all about unifying the creative and technical teams, tools, and processes in a way that reduces friction and boosts team performance of experience deployment. And today, we're going to get a firsthand look at how to implement it. So with that, I'd like to introduce our speaker, DevContentOps practitioner and tour guide, Tony Field, who is principal engineer and chief architect at Kingsway Digital, one of our key Crafter CMS implementation partners. Tony, we're looking forward to your presentation. Now, if you have any questions during the presentation, please ask them in the questions area below, and we'll take as many of those as we can at the end of today's presentation. And with that, Tony, the floor is yours.
Thanks very much, Russ. It's a pleasure to be here speaking with all of you today. Thank you again for joining and participating. That's right. So we want to talk about implementing DevContentOps. Today, delivering effective content-driven experiences really requires the unification of DevOps and content management. That is a fact of modern content businesses. So let's take a look at how we got here. Why did this occur? Over the years, as content management platforms have been deployed and used throughout businesses, developers have constantly had to struggle with making sure that they're working with current content, that they're working with content that is realistic, that works with the code that they've produced on one hand. And on the other hand, the business users that are looking at the content that's being, their content that's being rendered through their site, want to make sure that what they're about to launch and what they're about to go live with aligns with what their expectations are. And so a whole series of complex tasks and procedures had evolved in order to try to keep content in sync on all of your various tiers of your CMS platform. There are long delays between syncing these environments together. Developers are producing content with lorem ipsum text all over the place. Content authors and the teams that are ultimately requesting that these sites be built are not getting a realistic view of what their site is going to look like until after it goes live. So these are problems that exist right out of the gate. A unified process is needed to pull together managing the content and managing the code through the course of the lifecycle of a site and a deployment. Now, as these problems have come about and businesses have struggled to manage them, marketing teams and business users have taken fairly drastic steps in order to address this, at least from the perspective of corporate IT, and that is to do things like launch brand new sites on lightweight platforms that are under the radar of budgets, under the radar of central IT, totally disconnected from all of the organization's corporate assets. Those kinds of deployments may get off the ground nice and quick, but there's no integration between those systems and core approved content, core approved marketing assets. All these things are rogue deployments of solutions that are really very hard to work with once you start having to evolve them. So we really need a process that's going to pull all of these things together. We want to help developers deliver rich content quickly. We want business users to be able to see rapid results and realistic scenarios of content that's being deployed. So that's kind of how we got here. We need a solution to these problems. Well, a lot of organizations will have already figured out some way of addressing this gap. They may have cobbled together a series of processes, or the marketing teams have been trained to not expect to see realistic content. But the reality is companies are walking away from large investments in their content management assets in favor of lighter weight solutions because they're struggling to find a way of solving these problems. And so we've got to get on top of that. There's a go-to-market risk for these organizations that are doing that. We want companies to be able to react rapidly to new market needs. We want developers to be able to reproduce bugs quickly without having to duplicate an entire environment. We don't need to get a DBA team involved to replicate a live delivery environment just to be able to troubleshoot one bug. We've got to fix these kinds of problems. In a streamlined DevContentOps world, it is possible to find bugs in minutes instead of taking days just to get an environment stood up. It's possible to run shoulder checks with the content teams to check to see that the work that you're doing is producing results that align with their expectations. These are realistic shoulder checks using real live existing content assets. When DevContentOps is properly deployed, it's possible to deploy enterprise-grade features through plugin infrastructures that are designed for these specific purposes. So this is what it can be like if we actually have these solutions properly deployed. Let's take a look at some specific cases for how we're going to solve these problems. With DevContentOps, users get to see the changes that they're looking for much faster. They don't have to wait for the code that is being created for them to make it all the way out to production systems before they can actually test it with real content. So that kind of turnaround is very fast. Deployments can be much more rapid and much more predictable. So if you have a standard process by which code is moving forward and a standard process by which development and tests environments are regularly populated with realistic content, that greatly facilitates testing, it greatly facilitates user adoption, and ensures a smooth publishing process. It also greatly facilitates diagnostics, as I mentioned earlier. Developers are happy to work with systems like this because they know they're dealing with the real thing, with realistic content. They're using tools that are convenient for them, that they know and that they understand. And the process that the developers are adopting to make all of this happen are not unusual processes. They're not a completely custom one-off solution. They're using the processes and tools that they have learned over the courses of their careers. And that's very comforting for the developers. It's very efficient for an organization to work with those kinds of things, and it reduces the likelihood of errors. Standard tools make for smooth experiences, and DevContentOps delivers all of these. So let's look at what has made this hard. What we're talking about here seems like it should be fairly straightforward. We want to just come up with a normal process that will allow content make its way through the lifecycle of all of the various environments smoothly, and we need a smooth process for developing code. That should be easy. Well, it's not. There are major challenges that we have dealt with over the years to make this work. Content schemas are not static. They change over time. So you may have a simple article initially that's got a headline and a body, and then later on you're going to add in a byline, and then you're going to want to put in read time, and then you're going to add in additional fields over the course of the life cycle of the content, and that changes your schema, and that can result in changing your data model. And it can cause friction in an organization that has rigid policies around data modeling and that sort of thing. The content repository isn't often integrated with the code that actually runs it. On completely decoupled systems, there is no connection between the delivery and the schema of the content that's being rendered. Some kind of common ground needs to be clearly established, and that's a challenge to do. Database dumps to synchronize content, that's a lot of work. So if you've ever worked in an organization where your entire content repository lives in an invincible RDBMS, and that system will likely be managed and maintained by very skilled and very technical personnel that have proper procedures in place that need to be there in order to ensure that that core enterprise resource can be properly maintained. But the result of that is, or an effect of that, is actually getting that content into a local developer system, for example, can be a real challenge, if not completely impossible. So those kinds of things happen, and are challenges that we've got to sort out. I'm sure that if you've done any kind of development work to prototype a new feature, you've included this as a test in one of your demo walkthroughs. And that's the kind of thing that happens when you don't have realistic content to work with. How do we fix these things? Well, the answer is integrated DevContentOps with code forward and content back. So what is this? What does code forward and content back really look like? Now, I'll give a quick overview initially, and then I'm going to walk through this process in detail in a couple of minutes. DevContentOps allows you to seamlessly and naturally migrate content from your prod environment to your QA environment and to your dev environment, and then to local systems on demand and using standard tools. This is key. This is the one of the hardest problems with enterprise web content management solutions. This is a very hard thing to do, and this process takes that pain away and makes it a smooth, seamless, and familiar process. Naturally, you can also migrate your code all the way from the local developer's machine out to the production systems, again, using standard CI/CD practices that teams have become accustomed to over the years. Both of these jobs are done using common tools. Developers that are doing this work a lot of the time, or DevOps engineers that are doing this work, understand the Git semantics and semantics of a Git repository. And so we lean into using Git for both of these things. So that means that when we're moving content back from production into dev, or when we're moving code from dev into production, we're using the same tools to do that and applying the same rules and processes that we use for one for the other as well. So in order for that to work, we need to be organized. We need to keep a reasonably simple branching model that'll enable this kind of approach. And so I'm going to walk you through that. We need some specific techniques that apply to dealing with the content back and the code forward side of things. But this is not to say you have to adopt an entirely new branching model to use this technique. It is not about that. You get to use your own approach for branching for your code and your features and that sort of thing. But when you start interacting with the repositories, we'll guide you through some techniques that work very well. So another great feature that comes with this approach is that taking these techniques, the leads of teams can actually specify and decide when people get new content, when content is deployed to the lower environments and that sort of thing. That can be done by team leads. It can be done by senior developers. It can be done by anybody who has appropriate access in the repository. This approach, leveraging these tools, means that it's no longer necessary to adopt any kind of code freeze during deployments. You don't have to do code freeze for pulling content back into your lower environments. You're no longer dealing with publishing content to multiple locations at the same time just to make sure that you've got an environment that's in sync. It's a very simple, straightforward process. If you do happen to run into any conflicts or any troubles, there's a simple process for resolving those. And those are the techniques that teams already understand in dealing with conflicts in concurrent work. Also, because these approaches all leverage Git and Git semantics, there's a whole series of tools and techniques that are automated in these workflows that you can utilize with this system. And so if you want to ensure that your content is appropriately validated, you can do that through your CI/CD pipeline. If you want to make sure that you're maintaining clean code and that your code passes any kind of quality or security checks as you're deploying it, those pipelines still apply. There's no impact, there's no obstacle to continuing to adopt those kinds of capabilities. All right, so at a high level, this is where we're going. So how do we actually do this? What does this really look like? So I'm going to walk you through visually to try to bring this home. Imagine you have a few environments. You've got a production environment here depicted at the top, a QA environment for testing out your latest infrastructure, your latest code, a shared development environment for integration, for developers to collaborate on individual systems, on a common system, and then a local developer environment. As you do development in a system like this, you're taking your code that you've developed on your local system, and you're pushing it up to the dev environment, where it gets checked out and validated, up to the QA environment, where QA does their thing, make sure that everything is good to go, and that we're going to go into production with ease with this content, and then finally into the production environment for launch. This is very straightforward. This process applies for all sorts of software development, including how your website works. But we also want to bring content backward to the lower environments. So we've got content in production that needs to make it into QA and dev, and then even down to the local environment in some systems. So we need a way of bringing that code down into those systems, and this solution provides that. So how does that actually work? Well, this is all done through Git branches. We have a branch that models each of these environments. We have the local developer will be working on their own local system. They will produce code that's ready to go. They'll send it up to the development environment. Well, then where it'll get integrated, it'll get validated there and then pushed up to QA and then prod. But you'll notice that we still have the ability to pull content down through these systems. So how does that work? Let's take a look. Content originates not on the developer's laptop, but it actually originates on the CMS environment. And in fact, content originates on the production authoring system. So authors will log in to the CMS in the authoring environment, generate their content. That is the master content. That is the source of truth for content. Content that's approved and ready to go gets sent over to the delivery environment. And that production content is the kind of stuff that we want to pull back into Dev QA and local environments. So how does this flow actually work? Well, content that's created in authoring is published to the delivery environments. And we're going to have a delivery environment in QA and dev as well, so that we can test out what our sites are going to look like in that delivery and QA. And so we expect a normal flow, a normal publishing flow to occur between those systems. And in fact, that happens. But how do we get content from authoring into our Git repository? How does that work? There's a sync process that we can do with Crafter CMS that allows you to basically take content from the authoring environment and move it into the Git repository. That works in the same way that code is moved from the production Git repository into the CMS environment. And there's no special process there. It's the same process that you use when you're syncing a fork of a repository that you're working with. It's standard Git semantics that are involved in doing that. So we can see here that each authoring environment synchronizes its content and code with a Git branch, and each delivery environment receives that content from the corresponding authoring environment via a publish. There's no vertical arrows on the CMS systems or anything fancy happening over there at all. All of the cross-environment work is happening through Git using standard branching models. So this is the heart of the system here. Now, there are definitely technical considerations that are involved when you actually implement this. What you're looking at here is a high-level simplified view of what this process looks like on a system that has, dev, QA, and prod environments, as well as local developers. Your environments may not be this complicated. You may not need a full QA system on your system if you're working on a very small deployment. You may not even have dedicated dev. You may just work locally and push up to prod. This solution works for all of those kinds of environment configurations, scales both up and down. And I'll get into more of that in a little bit. But let's look at how more precisely this works. And this is kind of the most detailed view of this. What happens is Crafter authoring actually has a replica of a Git branch running locally in its own system. And we're going to call that the Studio branch. So you can see here, we've got it labeled as Studio Prod, Studio QA, Studio Dev. That branch there is synchronized with the Git repository on a regular basis, usually manually, and that's perfectly fine. But it can be done freely without any concern of any kind of negative consequences. Crafter is in charge of those branches, and they sync over to the Git repository. And when we push code from the production branch into Crafter, we actually push it up into the Studio production branch. And that's that black arrow you see at the top of the screen. In this black arrow, what we're doing is we're promoting code into the Studio environment. So we promote it up there, we run a sync, publish it, and you've now deployed all of your code across the entire system. And that process carries forward throughout all of the environment in your infrastructure. So QA, to do deployment into your QA environment, you will deploy code from the QA branch into the Studio QA environment branch, and then sync it over to the QA authoring server. And similarly for dev. So how do we get content down from the production environment into these systems safely? How does this really work? Well, the secret here is in the fact that what Crafter mirrors over into the Git repository is production content only. You'll notice that we take content from the Studio prod branch and we move that into the prod branch. And this is, again, if your environment supports it. Not all organizations will permit this. And so there are certainly ways that we can provide alternate content, but this is a general case here. So you'll take Studio content from prod, you'll sync it over to the Studio prod Git branch, and then you'll merge it into that prod branch. And you can then take that prod branch and merge it down into QA, dev, and even local environments as needed to bring production content down the stack in what's called a content backflow from production authoring environment down into QA, dev, and local. Notice that we're never taking content from Studio QA. We're never taking content from Studio dev. We're taking content only from the prod environment and bringing it down to all the environments. And that's the key. We know that QA teams are going to be busily making test content and trying and pushing the boundaries of the system in the QA environment. And so there's very important content that they've created in their Studio QA branch, and that's fine, but that should stay in the QA environment. And similarly for dev, we know what dev content can look like. We definitely don't want that in the production code stream. But production content making its way through this flow is perfectly fine. Okay, so how do we deal with a local environment? How does that work? Well, so the way I've shown this here is we have a local developer machine. They're going to take a fork or a clone of the dev environment branch, typically, or the dev environment. So they'll have their own version of the dev branch that's shown in the dark green at the bottom. They'll also have a copy of Studio Dev, so they can see what the content looks like in the shared development environment as well. And when they spin up their new Crafter environment, they're going to spin that up based off of the Studio Dev branch. And I've labeled that developer environment Studio Local. So that's what a developer will be working on if they're running Crafter on their local system. They'll have their own branch. So they've created that. It's a standalone instance that they've created just to do their development, but it's based off of the content that's sitting on Studio Dev, based on everything that's on Studio Dev. And remember, if we go through our code forward, content back cycle, Studio Dev will have production content in it alongside other content that is a developer only, and that's usually fine, usually suitable actually, or ideal for developers that are actively developing new features that may not be fully implemented. So local environment is a replica of Studio Dev, which matches what's on the actual dev environment, which has production content from the previous run ready to go. The developer can then create a feature branch off of their local copy of the dev branch, do their development there, or however they like. But ultimately, they're going to run a pull request up into the dev branch in the main Git repository to have their code incorporated into this flow. That's the real secret. It doesn't matter what happens, on the local developer machine, really. But what does matter is that when that push is done, or when a pull request is created to get code into the main dev branch, that process is clear, that it's standard. And what I've found works very well at a few customers that I've implemented this with is that we issue those through a pull request. And when that pull request is merged, we do a squash to have that entire feature be included as one commit into the repository. It works very, very smoothly. Now, if we're doing work on a Crafter environment, you've been working inside the Crafter interface. You may have worked on some configuration files. You may have used the UI to create content types and that sort of thing. How to get those changes back from our Studio local environment back into my developer branch so that I can actually incorporate those and send them up the line. We're not syncing. You see there's no sync arrow back and forth between my local branch on dev and what's happening in Studio. That's more than we need. So what we can do is we simply generate a patch, and your IDE will help you do this process efficiently. But usually it's a matter of selecting a couple of commits that you like, generating a patch, copying it to your clipboard, and applying it into your dev branch. And that provides you with the features that you've implemented in Crafter that you're ready to push in your pull request up to the environment. So that's the flow. That's the sort of the heart of the flow. There are edge cases, and there are some specific scenarios that I'm going to get into in a minute, but this really is the heart of the system. It works beautifully. It scales to small deployments of just a couple of developers, all the way up to large teams, multiple sites, and that sort of thing. Okay, so let's get into some more detail here. You can definitely vary the system as you need to. What I've shown here uses, I don't actually break out where these branches actually live. These branches can be in their own repositories if you like, or they can be in a single a large repository that holds all of prod, QA, and dev systems. Either solution works. There are pros and cons of each. Large deployments with separated content, separated repositories will allow you to segregate content so that prod content is not available or visible into lower systems unless it's been approved through a proper sync. It's simpler. You only have a couple of branches per repo, but you have more repositories to manage and that sort of thing. Developers can either clone the main repository and do their work there in their own branches, or they can fork it. Either solution works perfectly fine. And in terms of what you do down on your local developer system, it's really up to you. There's a lot of flexibility. The solution will mesh very smoothly with standard development processes. So how does a developer get set up with a system? It's pretty straightforward. You'll clone your local dev repository, point your development environment at the clone that you've just created, and then you'll create a studio environment off of that studio dev branch as an orphan. And that's this step here, right? So where we're actually creating the new studio environment as an orphan. So in other words, when you create a site as an orphan in Crafter, you're basically saying, thanks, but no thanks. I don't need the Git history for this item as I'm working here because I really just care about having an environment that's up and running, that's a replica. This is a kind of disposable instance that you can create on your local. You can recreate it on demand as needed. Large volumes of content take a little bit longer to create than smaller sites, but it's a very reasonable process for a developer to do as part of their setup or when they take on a new ticket to develop. But we want to do that as an orphan. So you're going to point your IDE at the main dev branch, and you're going to create a studio clone off of a studio environment off of the studio dev branch of your system. Once you've completed your pull request and that's been approved, you can then resync your fork or your local branch to pull content and the latest code that you and your colleagues may have worked on into the main system. So throughout all of this, you might be thinking code and content in the same repository. Is that really the way we're doing this? Yes, that's the way we're doing this. The content and code live in separate places in this repository, and you can utilize Git semantics to segregate things if necessary. But as a general rule, your content lives in a specific path on a Crafter deployment inside the site and static assets content folders, and everything else is code. So you can set up your Git policies to enforce these kinds of rules, and things will maintain a reasonable degree of simplicity and avoid any kind of complicated conflicts with this process. But the reality is that merge conflicts do happen from time to time. Anyone who's worked with a large team has no doubt run into these kinds of things. And the short answer is you manage merge conflicts in exactly the same way with this process as you do through normal development. If you follow these rules pretty closely, you won't really run into conflicts that often, but it does happen. Sometimes you'll do some editing directly on configuration files on the server, and those will have to be reconciled with any changes that have come through those files through the development process. And you got to sort that out. And so you'll be prepared to deal with those kinds of conflicts, usually very straightforward to merge. Sometimes you'll run an upgrade on your system and you'll trigger a conflict, and that'll trigger a conflict on a couple of files, and you want to manage those. But if you can coordinate your upgrades to follow the same flow as your code process, local, dev, and test, then prod, then you'll reduce the number of conflicts that you wind up with there. There are a few files that are common touch points on Crafter deployments, like content model files, site config files, and again, just watch standard Git semantics for common touch points will apply in there and in those files, and you use your regular merge tools to address those kinds of things. So it's a very straight, there's no secret here. You're just using the same processes that you've learned and worked with throughout your time in working with Git and with code to manage all of these kinds of changes. Now, when you're doing the content back, there are a couple of additional things that we want to deal with. You're going to end up with occasionally the same content will be modified in multiple tiers. So production content will be created in prod. It'll be moved through content back into the QA environment. The QA team will make some adjustments on that content, try a couple of special characters or whatever is that they're doing. And then we'll run another content back, and now we've got a merge conflict. And so those things will arise, and those are generally few and far between, but they're also really obvious to resolve. And again, standard resolution approaches will work perfectly fine for you here. So you can usually trust the content coming back from prod. If you have the QA team work on their own content in those environments, have devs work on their own content and just kind of visualize what things look like using the prod content, you'll reduce the number of conflicts that arise there. If you're using blob storage with Crafter, you'll be working with S3 to store the actual binary content, like very large objects. And so there are sync semantics that you'll need to adopt whenever you do a content back. And those processes are documented in Crafter's DevContentOps guide. But it's a very smooth and straightforward process doing blob syncs. So I wanted to talk about a couple of examples of this in action that I think will make a lot of sense. Large video and video on demand streaming broadcasting organization with over 50,000 pages and content instances. Site was developed with a very large initial development team, and it was taken over by a small team after launch. And so we needed a robust DevContentOps process to keep things organized with that large team and with all of that content that we were dealing with and multiple iterations through the launch process. That adopting this DevContentOps process made it really easy to spot problems that arose. Content that's coming in through video systems does change from time to time. The structure can change. The feeds are not always fully conformant. And so you need to be able to see that content, to work with, to troubleshoot things, in order to figure out what's wrong with your code, like what didn't work, or what's wrong with this content, why are things not behaving the way we expected. And having a smooth DevContentOps model in place makes that work very effectively. It's really easy to spot issues, and it's really easy to manage deployments of these complicated systems with a common approach that's endorsed by the vendor, and as well, and that's understood by all members of the development team. You have a very smooth process in shaking out any issues that arise. And then, in this particular case, it was possible to simplify the deployment architecture of the DevContentOps deployment model from the more complex multi-environment system into a slightly less complex version as the team evolved. And that's one of the wonderful things about this process, that is that you can adapt it and size it up and scale it down as you need to accommodate your team. So another example, we've got a fast-paced B2B, B2C organization, lots and lots of enterprise sites sitting on Crafter, developers and QA both working in parallel, and those organizations need standardized practices that organization needs a standardized practice to fit into its existing CI/CD processes. The development team has their practices that they've come to work with, and their training materials and infrastructure are all aligned. And so we need a standard process that can fit into that. And DevContentOps is that process that we adopted. We have incorporated automations into this process. We've incorporated multiple environments, different kinds of automations, different kinds of checks, validations through the course of all of the environments on this system. And that has worked very smoothly to ensure that the teams are able to manage multiple sites cleanly and in a consistent manner. The DevContentOps approach is also very effective, even for incorporating legacy sites into the flow. So once a site is brought into the standard approach, it's possible to then continue debugging, continue releasing new features with previews, and get new features out to customers smoothly and rapidly, and with everyone on the same page for how content and code flow. It's very easy to work with these solutions. So both new projects being deployed on the DevContentOps model, as well as existing legacy projects being brought on board, can work equally well throughout this system. So to conclude, employing a DevContentOps approach, it simplifies the hard problems of code forward and content back. The solution ensures that the DevOps teams are happy, that they're working with systems that they understand, and processes and procedures that resonate well with the way they've been trained and the way they work, and the processes that are in place in your organization. And that makes the entire development team more efficient. And that means new features get to market faster and bugs get squished and put out of their misery even sooner. So that's an overview of DevContentOps and code forward, content back, how you can actually take these features and deploy them realistically in your organization. My name is Tony Field. I am with the Kingsway Digital Company, and we are a Crafter partner and a solution provider. We're happy to help. If you're doing any advanced work with Crafter, please let us know. And with that, I'll turn it back to Russ and say thank you very much.
Thanks, Tony. This is great material, and we really appreciate it. We do have a couple of questions, and it looks like a lot of them are sort of drilled down on some of the things you talked about. Maybe we can go through some of those. So the first question here is, what's the blob store?
What's the blob store? What's the blob store? Great. So, Git is a great repository for storing text files and the kinds of files that we work with when we're dealing with code. And a lot of the time, content that we're working with, especially enterprise content that's carefully curated and managed, will go through various different phases of its life cycle. There'll be edits, there'll be tweaks and adjustments. And the reality is, with enterprise content, you want to be able to see how that content has evolved over time. Has it been changed? Has someone tweaked a headline? When did we misspell that word or whatever? And so Git is perfect for that, but it's not perfect for videos, and it's not perfect for 25 megabyte PDF files and that sort of thing. And so while if you've got a few of those files, it'll work perfectly fine. But once you're getting into like large volumes of that kind of content, you need to take that content out of the Git repo and put it somewhere else. And so Crafter's solution to this problem is to link content from within the CMS to a location on a blob store, and that blob store can be implemented using a dedicated file system, or basically pick your plugin. But the standard deployment architecture for that is to use S3, so which is Amazon's large file storage solution. So basically, when you upload a video through the Crafter CMS repo, the system will seamlessly store that content onto S3 for you, and it will manage its lifecycle properly for you. But when you do a content back, you're now not relying on Crafter specific technology to do this. You're using your standard DevOps processes to manage that content. And so you've got to pick up both the Git repo and the blob store content and take it and bring it back into the lower environments. So you'll use Amazon Sync tools for that. It's a one-line command that you'll run to sync the latest changes from, like, say, QA down to dev and that sort of thing.
Great. And just worth noting, I guess, that the AWS blob store, it's really AWS compliant blob store. So if you have an on-prem installation and you're looking for something that's not AWS, you can use MinIO. There's Oracle implementations of AWS S3 and so on. So any S3 compliant interface will work. Here's another question. Are the branch names that you showed in the diagram a requirement, or are they a best practice?
Sure. Yeah, no, these are definitely not a hard requirement burned into the code base. They are a best practice, though. Standardizing the approach we use makes it a little bit easier to have conversations around this kind of thing, but it is absolutely not a hard technical requirement. These terms and approaches have evolved over time until they've most recently, the DevContentOps best practices is a fairly recent document with Crafter, and it reflects the refinement and changes over several years of deploying this architecture, and we think these terms work pretty well and are pretty transparent. But if you've already got a similar solution in place, there's no need to make any changes to your existing branch names or anything along those lines.
Great. And the branches that are shown here, are they the only branches that we can have, or can we have our own branches?
You can absolutely have your own branches. The ones that are shown here are kind of the minimal set for each tier of the environments that are listed here. So, you'll want to have that studio dash prod branch in place to be the mirror of what is in your authoring environment. That's really important. And then you'll want to have that be separate and distinct from the branch that is the one into which you move your sort of ready to go to prod code base, because they need to be separate so that you can keep the code and content separate. So this shows you kind of the main pieces that need to be in place, but what you do beyond that is completely up to you. So if you want to spin up a couple of variations of the dev environment, you may set up like Studio Dev 2 and Studio Dev 3 based off of the dev branch, where you have, maybe a dedicated deployment of Crafter that corresponds to a feature that you're working on. That's still based off of maybe a feature branch, or maybe based off your dev branch. So it's really very flexible. But if you're going to deploy an environment, you want a dedicated branch that links back to Studio, and separate branch that is the target for where code that's about to go there is promoted.
I appreciate that. And I think it's important to, just kind of note that, these diagrams, they show the part of the process, which is really moving content between environments, which is one of the main problems people have with traditional databases, right? It's just being able to get, production content back to a lower environment seamlessly without interfering with the authoring processes and so on. But it's difficult in one diagram to show necessarily the whole workflow, a whole development workflow per se, and also the timing of things, because you have, with these different repositories, you have control over the timing of when these activities happen, and at different levels. I mean, you may have a sync from production down to, let's say, a QA environment that happens very regularly, but a development team that is maybe just about to go to integration testing, they may not want the latest production content the day before or the hour before they're about to do their integration testing. So because they have their own branching structure and their own development process and potentially their own environment, they can control when that content from production is pulled into their environments. They could say, well, let's hold off, let's get through our integration testing, and then after we do that, let's get the latest content and retest, and having that delta is information rather than risk. So I think there's some real power in that pattern, but it can be difficult to show in some of the diagrams. Let's see, another question here, and this maybe goes right to what we were just talking about with the diagrams, is how do you ensure that lower environments are always in sync with upper environments if content is always pushed to production first? So this is something that, I would say right off the bat, is something that we are kind of making an assumption here with this presentation about how production content is created and some of the inner workings of the workflow and sort of what we might call environments for authors there that is not shown in the diagrams. But maybe, Tony, can you elaborate on how we ensure that the lower environments always stay in sync with the upper environments, given that we work in prod?
Yeah, absolutely. Again, prod authoring is the source of truth for content. That's really where it originates. It's kind of like the future state of what's going to be live on your site, right? Once the content goes through process, gets published, it gets approved and published. That's the real deal. And And that content is usually safe. Again, not every organization is going to be okay pulling content back from prod. Like there may be some constraints. You may have to filter it or do some redaction, and that's totally fine. And there's a separate conversation related to those things, but there's a process that allows that to occur. But basically, moving content back into the lower environments is the heart of content back, and that's what's shown with like these magenta or arrows pointing downward. So a normal crafter git sync is what gets the content into the studio prod branch over here. At the top here, and then it's a normal git merge that pulls the content down from studio prod into prod, and that's how you get real content into here. And remember, the code is working its way up the system, and so every commit that is in prod has already been in QA and in dev, and so you're not going to be causing any trouble by taking the prod branch and merging it down into QA, because all the code's already there. It's already been through the process. You're not going to overwrite anything. Git is smart enough to handle that. But it will bring the content down with you safely. And that's why this process can be done so like on a repeated basis. This is not something that you have to like carefully plan for, the end of the month after you've been able to line up like all of your IT teams. Like this can be done on demand to bring content back into the various environments. And so, realistically, when content gets a little too out of sync and you want to sync it up again, just run a content back operation. It takes a couple of minutes and off you go. I don't know that you need to necessarily go to the trouble of automating that. It's normally not that important to do. You want this content there, but it doesn't have to happen all the time. Usually like every few days or every couple of weeks if development is slow on a particular feature, or if the content changes are of no importance to the development work that's going on. So yeah, it's this content back magenta arrow that's a process that can be repeated, on demand safely that allows content to stay in sync on the lower environments.
Great, thanks. And what about you mentioned automation here, and I think the very next question was, is there a way to automate content flow from my upper environment to my lower environment?
You can. We're in Git here, so these are standard Git semantics that apply. And so, if you want to do that, you absolutely can. You will need to have a solution in place for dealing with merge conflicts. They're not frequent. If you're going to automate it, I would impose some rules. I did mention those in one of the earlier slides, and this is actually called out in the DevContentOps white paper. That is, if you are going to go through the process of automating content back, you do kind of want to carve out an area for QA to do their work and for dev to do their work, so that when they're creating content, they're creating it alongside the production content as opposed to modifying the production content that's been pulled back through content back. That just keeps the number of conflicts down. But no, to automate this, you're just using straight up regular Git rules and Git actions and Git workflow and standard CI/CD processes. So automate to your heart's content. There's no problem doing that.
Yeah, and Crafter also provides some APIs to help from its perspective with push and pull, and those APIs are JWT enabled, and they're pretty easy to integrate with some of the standard CI/CD tool chains out there. Let's see here. What about here's a great question. Who should be involved in defining the DevOps process?
Yeah, so I think so I would certainly involve the DevOps team, of course, right? But you're going to want to you do need to go through the process of educating them as to how Crafter Studio works and how we do have a need for this studio prod, studio QA, studio dev branches in the repository for this solution to work smoothly. So it's they'll if this is a new if this is a new concept for your team, these branches will be seen as kind of like all right, well, that's interesting. That's it's kind of an unusual aspect from their perspective, but it's also just another branch, and so not inherently different than what would happen like down on a normal developers interacting with a repository either. So from that standpoint, it's usually okay. But you're going to need to have your DevOps team. You're going to need the CMS solution architect involved in the initial setup. And if you're planning to deploy different kinds of environments, you'll want to know what tiers are involved so that you can set up the branching flow smoothly. So I think those are probably some of the main parties to have involved in that initial setup process. Typically, DevOps, the solution, and then anyone's going to be basically interacting with both craft, like the lead that's organizing the way the crafter is set up, as well as anyone that's doing sort of extensive work with Git.
Great, thanks. Well, that looks like all the time that we have for questions at the moment. So with that, if you'd like to share the presentation with your colleagues, we did record it and we will make it available online shortly. If you're interested in learning more about the DevContentOps topic, we do have resources available online at docs.craftercms.org. And we also like to invite you to take a look at devcontentops.io. It's an entire site dedicated to this subject. And there's also a newsletter that you can sign up for. So that's a great resource. And with that, I'd like to thank you, Tony, for sharing your experience with us. And I'd like to thank every one of our attendees here today for your time. And thank you and have a great day.
Thanks very much, everyone.